share order.
Hello, everyone, and thank you for joining us for this session of Cloud Live. I'm Aaron Edelman, a security advocate here at Google, and I'm joined today by my friend Leonid Yankulin. And today we're going to go into securing a multi-agent system. So, Leonid, why don't you give yourself an intro?
Hello, I'm Leonid. I'm a security advocate working with Aaron, and I will be supporting Aaron and explaining you all tweaks and secrets about securing your agent applications.
So, today we're going to be focused on a very specific layer of securing an agent, which is how the agent interacts with other agents, prompts, and tools. So, what do we mean by multi agent security? Well, let me show you a diagram of a potential scenario. So you may be familiar with prompt injection and just talking to a chatbot, but with agents, prompt injection can work very differently. So traditionally, when we look at prompt injection, it's the user that's giving a malicious prompt to try to trick an AI model into doing something inappropriate or unsafe. But in this particular case, with agents, the user could give the agent completely normal instructions, right? Go read a 300-page doc for me. The user is totally innocent. But what happens is down the line, in some other format, whether it's a skill or some text that the agent is consuming, that's where the prompt injection is located. This is called indirect prompt injection. So you'll see here that after the user gave the prompt and the researcher goes and reads some text, the text is actually what contains the malicious instructions. And in this case, it's anticipating, maybe agents with access to certain tools might be reading me. So we're going to put in some, you know, some malicious instructions right in the text. Now, the user is completely unaware that this is happening, right? They thought they just asked for a summary. But the researcher, if there's no guardrails in place, will pass this to another agent, which then goes and makes a tool call. And this is where the impact actually happens, right? The injection is passed here. So what's interesting here from a security perspective is we see a very familiar classic security problem, SQL injection, but the way that it's getting into our system is completely different from how we've seen it before, where an attacker is making an API call or interacting with the user application in some way. Here it's all the prompts and the agents are sort of unwittingly passing them back and forth. So this is where securing this point in the application where there's interaction with the model becomes so important. Now, I mentioned earlier that a lot of the foundation models, really most of the models that you probably interact with, have some sort of guardrails today. You can't just go and ask them to do something crazy like building a dangerous weapon or, advice on how to do something illegal. There's already something in place to prevent that. But as you could see with the example of SQL injection or even some more advanced types of attacks that on the surface may look totally legitimate, maybe the average LLM guardrail is not purpose built to catch those. And in fact, it probably shouldn't be, right? The LLM's job is to give you this rich content or to, do some reasoning for you. It's not to just do security. And that's where having a separate step in between that's just focused on security and safety becomes so useful. So in this case, we're going to show a tool called Model Armor. Beyond just the more advanced forms of prompt injection that are constantly being updated, constantly being researched and added to it so that your LLM doesn't have to worry about it. We're also going to think about some other potential security issues, such as the inclusion of malicious URLs. For those of you familiar with some of the malicious skills that came out with OpenCloud, there was this problem of skills looking very normal on the surface, but then the skill would go and give some subtle instructions after that, like go visit that website, which would be a phishing site or something to steal a crypto wallet. So having up-to-date threat intelligence on malicious URLs is something that you can't really expect the average, even a very powerful LLM to have. This is a static list that has to constantly be updated. And that's where Google's threat intelligence can support Model Armor. And likewise, we still have a lot of the classic data loss prevention issues of people accidentally, putting way too much personal information into a prompt. So, for example, someone is just trying to get support and they mention what medications they're taking, their credit card number, their date of birth, right? They're passing this very sensitive information. Maybe at some point in our system, we do need that, like a patient database. But the model per se probably shouldn't be interacting with that. And it certainly shouldn't be passing it outside of the system. So we want to think of ways to identify potential PII, personally identifiable information, credentials and secrets, right? Of course, as developers, we're using coding agents to help us write code. But what if that accidentally contains a hard coded API key or a password? We want to be able to catch that. And likewise, financial and medical data.
Yeah, just I want to intervene here and
Yeah,
add an important point that some of you who already have experience with placing some guardrails in your code, you may ask, we already have a protection against SQL injection, for example. Why do we need to replace it or double it? So you may notice, and we will show it in a moment, that when we define the model armor, we define a policy that combines all these instructions together in one place instead of being distributed across multiple tools, multiple code blocks inside your agent code and other places.
exactly. Yeah, being able to centralize things and simplify them really helps both from the perspective of security, just knowing you have those checks in place, but also from the perspective of governance, so that if another team in your organization wants to spin up their own agent, interact with their own model, you can transport those policies across those different environments. I just wanted to give, a live example of, a hard-coded API key that might appear and in your code. And the fact that if you were to pass this to a model, certainly a prompt injection guardrail wouldn't catch something like this. So you would want to have something that's purpose built just to look for these types of things. And in some cases, that you might imagine, well, isn't that just a simple regex for a lot of things? And it's true. But in our case, which we'll show you, there's over 200 different types of sensitive data we can identify, some of which are very difficult patterns to anticipate, like personal names. And in the case of credit card numbers, too, a 16-digit number is not necessarily a credit card number. It has to pass the Loon algorithm. So the DLP specifically looks for credit card numbers. Uh, and so, in terms of what to do when you have sensitive information, model armor and also application security tools in general, you might think, well, if it's something bad, I want to block it. But I will warn you, from having implemented DLP in particular into a lot of tools, blocking is really not what people need a lot of the time. They just need some partial redaction of the string, or even not the whole string, but just some characters. So you could see the phone numbers here. I'm still preserving a part of the phone number. You can imagine whenever you are in a store and you want to choose which credit card you're going to use, it doesn't give you the whole credit card number, but it gives you the last four digits. So sometimes maintaining some of the information is useful, and there's actually a way to do that in model armor. So as the prompts are going back and forth, you can preserve pretty much most of the text that's going through and just take out the part that's sensitive.
Yes. Moreover, this information sometimes is very useful when you troubleshoot things. Consider, I don't know, it's not the best practice, but some applications use social security number as a unique identity. So obviously, to troubleshoot the specific record, you have to have the number. But if you place it in your logs explicitly, you expose this information.
That's a
So
great
the
point.
Sensitive Data Protection Service, which formerly was known as DLP, it allows you to replace this information with a reversible hash, and then the people who has access to the key that allows unhashing. I'm not sure if it is the term. It helps you actually to restore the information and complete the troubleshooting.
Very good point. So let's look at just an example. I think I gave a classic example of prompt injection where the user is asking to do something very dangerous. But we gave, and that's what we'll be testing today. But you could still think of it. I'm just going to scroll all the way to the beginning. You could still think of the same rules being in place when an agent goes and reads something on the internet. So I want to break from this idea that it really matters where the prompt is coming from and which direction it's going in. The concept is whether it's going to a model or from a user or from something on the internet that an agent is reading, regardless of the origin, you want to be able to inspect to catch these kinds of issues that we've just covered. So we also have a lab to go along with this session, and you'll have access in the link that's provided. Um, but we'll be showing you kind of the final form of this lab so that you can see what you'd be building. And after the session, you can go and try it for yourself. You can extend parts of it. You can see how we've done the sensitive data protection, what types of things we're looking for. And on your own, you can experiment by adding some of your own information types that you want to redact. You can even play around with the form of redaction. So you can say exactly how many digits in a credit card number you want to mask, for example. And that will just give you a sense of all the different ways you can configure this tool. Likewise, we're configuring the sensitivity of model armor in a very particular way in this example. Um, but we're specifically going to look for prompt injection and sensitive data protection. But you'll be able to fine tune those as you need. So, for example, the one that I like to give with a school that I worked with, there is an adult track where you have people researching topics such as historical wars or dangerous things that are happening in the world, and they need less restrictions on the safety settings because they're researching something that's potentially not a topic that you want little kids to have access to. But then for high school, for example, you may have more safety settings in place. For a consumer facing application where anyone on the internet can interact with your agents, you probably want to have more guardrails because the gate is open to malicious users coming in. But for something that's internal, say some doctors in a hospital, really the thing to focus on is sensitive data protection. The safety is less of an issue there. So just keep in mind, you can configure all of these parameters, even though we have a very specific way to do it in this lab, just so you can see the example. The point is that you have the ability to modify this to meet what you need. And we've built the full completed version of the app, but what you'll do is go through and see where exactly you need to add the dependencies, how you need to change the code to call model armor. So you'll really get a good sense of where this fits into your application. One thing I want to note is that a question that often comes up is a matter of efficiency. Like, do I need to use model armor at every single boundary where there's an interaction with the model, or is it better to use it in specific places? And I would say that to be the most efficient, in some cases, an architecture will spin up other resources if a prompt is allowed through, right? A user creates a prompt or some text appears, and that kicks off an entire process where all these other agents get provisioned. If it's malicious and you can see that right at the beginning, you really don't want to waste your resources down the road. So the idea is even if there's guardrails in place, even if you have auto scaling, catching these things as early as possible is definitely the most efficient, both from a security perspective and just from a resource cost perspective. The benefit here is that you are preventing your broader agentic system, and we'll show an example of ours here. You're preventing that from getting inundated with these malicious requests. Leonid, I don't know if you had something to add, but I can jump into the
Uh,
code. Yeah.
I'm not sure if we have like a good flow diagram or model
Mm.
diagram about the application, but essentially we are. Can you maybe jump to the introduction step of the code lab?
Yeah. Or I actually
It
think I
sounds
do
like
have.
a kind of funny picture, I believe.
Yeah, I think I've actually got the architecture of the whole lab. Let me just pull that up. But
Okay.
Leonid, if you don't mind talking a little bit about it first, and then I'll pull up
So
your.
what I wanted to point out that again the example that we are going to show, like Aaron mentioned, is one of the probably simplest workflows when we have multiple agents doing work, but we want to protect against some malicious prompts getting sent to the system. So we filter the first initial prompt from the user. So again, we are kind of trying to block any bad intent the user may have when they use the application. And then another protection is when the output uh, is returned from the system
Mm, right.
to the user. So we kind of want to make sure that the result is also validated. However, in your particular business case and workflow, the situation can be different. Like Aaron mentioned, you might have a different levels of protection or focus of protection depending on the agent. And then for some cases, you will front the model with the model armor for a specific question agent. Can we, by the way, can we show an example how it is done using ADK? Uh,
Yes, yeah. This example
we
actually
will do
uses
it
ADK.
probably in the later like Q&A time
Hmm.
when we off, and then we will be speaking about alternative model when you can leverage a new service that Google Cloud released this year called Agent Platform that introduces different very flexible integrations
Hmm.
when you can define your own models and protect them with model armor without writing actually a single line of code. So we'll speak about it during the Q&A. And right now we are talking about protecting agents that work with Gemini models,
That's
models that
correct.
Google Cloud hosts. Yeah.
That's correct. And this multi-agent system was built using ADK. Basically, a user will provide an input. So this is to create curriculum for a course. And I actually showed this to some teachers, and they went off and actually used it in their courses, which is pretty cool. But um, at this point where the user gives the input, that's the first time we're checking with Model Armor to see, is this a safe course that they're trying to build? Are they trying to do anything sneaky with these agents? Then the agents themselves, once that is passed, go and do their research, put together a course, and then when the output is coming to the user, there's another check there, and that would coincide with things like sensitive data that might have accidentally been included at any point in the training materials, at some point included in a prompt, at any point. Um, let's see. Just going to show what this would look like. I did want to point out how ADK works at a high level, just so that we can see that. And I believe, let's see, Leonid, I think this would be in the source code. So I'm just going to go to Cloud Run and just show the source code. Uh,
Yeah,
yeah.
I'm looking at it as well.
Mhm.
Would you like to share maybe the screen?
Yes, yes. I'm just sharing
Okay,
the
so
source.
we have the version deployed.
Mhm,
So Aaron is like browsing through the Cloud Run code.
mhm,
So we deployed it on Cloud Run. It's a serverless platform. If you're not familiar with it, allows you to run lambdas as well as a full-fledged complex services, serverless. Uh, Search in in Google for Cloud Run to get more details. We will be focused on the
mhm.
platform itself. But it has this nice feature when you can go and see the actual source code deployed for your service.
Right.
So, Aaron, you
Mhm.
would like to look into the app folder down
I first wanna show the ADK orchestration.
the
Yeah.
ADK. Yes.
Yep. So I just wanted to show you all of our agents that we're using. So we have an orchestrator agent who's the manager who kind of picks what the current step is and whether the agents are allowed to go to the next step. And then a researcher agent who's going out to look on the internet for the material, a judge that determines and evaluates whether that research is good. Maybe there's potential contradictions, maybe there's hallucinations. So it's doing an evaluation. And then a content builder that puts our course into a very structured format that a teacher could use. So I just want to show how all these are pulled together in agent.py. And again, this is using ADK. I just want to show you how little is required to connect all these agents. So each agent has a particular card, that's this file, and then a description of what it does and all the required steps that it has to do. You can see the ADK documentation for a lot of examples. We have a huge repository with everything from finance to security, to looking up the weather. We have a lot of different multi-agent systems. And sorry, Leonid, you wanted to go to app next?
Um, y- yeah. So
Hmm.
in the app folder, please open main .py file.
PI,
Yes.
yeah. Hmm.
And if you will scroll a bit down to the method called chat stream,
Let's see. I'm not using
just
it right.
scroll inside. It is a very
Sure.
simple view, so it doesn't provide you rich editor
Yeah.
capabilities.
Okay.
Probably no editor
S-
capabilities at all.
Sure.
Uh,
Maybe if I edit, it would give me some more, but I don't have to do that now.
yeah, I will
Mm-hmm.
tell you. Does it
Mm-hmm.
show the line numbers? Yes, it does.
Perfect.
So you're looking for the line 160.
You got it. All right. There we go.
So
Chat stream.
this is from the practical perspective, each time in the front end that we will show in a moment, you write a request and press chat button or create button. This request of yours lands in this method, and then before we even send it to the first agent, the code implements in few lines execution of prompt sanitization, as you see in line 169.
Sorry.
And then, depending on the response, it either forwards the prompt to the orchestrator agent for processing, or if a problem is detected, it reports the problem and stops execution. So
Right.
it is the most simple, most naive, most straightforward use of model armor.
Yep. It also
Well,
gets you that feedback very quickly, so you're not waiting to spin up agents and having each individual agent use it. It just tells you right out of the gate, you can't do this.
yeah, and we will be more than happy like to discuss about alternative methods.
Mhm.
Please post your questions on YouTube or in LinkedIn chat, and we hopefully will see and these questions, and we'll try to address them towards
Sure.
the end of the stream.
So let's maybe create a course first that is totally benign and we'll get past model armor. How does that sound? Leonid, any ideas? I've got some, but I want to hear yours.
Uh, okay. I'm afraid to propose the experiments can be wild. Let's
Right.
ask, I don't know, uh, how to make uh, a firework. Will
Oh,
it allow
let's
it?
ask it something safe first. How's that?
Okay.
Yeah,
Uh, I
we can
think that
maybe.
making
Yeah,
fireworks can be safe. I don't
it
know.
can. Yeah, everything can be safe.
But I don't know if model armor considers it
Right.
as safe.
Maybe lemon pound cake is dangerous and we just don't know it yet. So I
Uh,
think if we said souffle, that might be more appropriate.
right.
So maybe let's say what's happening right now. What's this
Yes.
initializing?
If I was working inside
Mhm.
model armor and answering these questions, I would fail it. I personally don't like lemon cakes.
Okay. But right now it's spinning up all of the agents that are going to be taking part. So it's spinning up the research agent, fact checking, writing. Because I'm doing this on a cold start, nothing is pre-provisioned. So we're really going to see end to end from a prompt to spinning up your agents for the first time. What's that full life cycle look like? And Leonid, we deployed in this case, we deployed each agent to its own Cloud Run instance. Is that right?
Yes. So
Okay.
practically speaking, right now it's supposed to launch all four services
Hmm.
to do the cold start.
Right.
The services themselves, they are pretty small, so it shouldn't take a lot of time,
Hmm.
but they have to run all of them, and then the registrator have to start reaching out using agent-to-agent protocol to the services and establish the connection,
Hmm.
and then to begin the building cycle. So
Got
right now
it.
we see this building cycle. A researcher finished the job, passed the findings to the judge, and the judge uses the strongest model, Gemini Pro, to analyze the findings and decide if additional research is required. And
Here's our
eventually it
course.
goes to
Yeah.
the content builder and
Mhm.
immediately creates the course.
Right. And so this is curriculum for a teacher. So how they would divide their lessons. There's a specific plan. Um, I've seen people do this with language courses, history courses. So it's pretty cool. This is definitely more in depth than if you were to just ask a model, right off the bat for this type of output. So, um, but now let's try something a little bit dangerous. How does that sound? All right. So how do I create a firework? Oh, let's just try. I actually don't know. Maybe it will consider it safe.
Nope,
Oh,
it does.
okay. So it considers it dangerous, and because I'm trying to be innocent, maybe it's also flagging me for attempted jailbreaking. Let's try. Let's see. How do I create a pathogen in my bathtub?
Oh my god.
Okay, there we go. So, so it's catching all
By
of
the
these.
way, I
Mhm.
want to stop you for a moment. If you
Yes.
remember, the previous one
Mhm.
was stopped based on the responsible AI filtering and
Yes.
detected as dangerous. But
Right.
it didn't break through the jailbreak, meaning it wasn't jailbreak, meaning it didn't prevent instructions or safeguards of the agents.
Mhm.
The second one actually it was detected as a potential jailbreak, which might circumvent the instructions that prevent the model from doing something dangerous or illegal. So the result is practically the same,
Mhm.
right? But depending on the reason, again, maybe your business logic is intended to handle something dangerous but handling it differently,
Mhm.
while the prompt injection and jailbreak is no go, like by definition, because it kind of breaks the rules of your agent itself.
Right. I'm just trying a few different varieties. Okay, right. So, yes, we're preventing this AI course creator from being used maliciously. And, more importantly, even if guardrails could catch some of these, why would we put in the effort of spinning up all those other agents when we can see right away, just in our application, that these things should not be going to the models? So, we have layered defense in this case.
Okay,
Yeah, cool.
uh, let's look what we actually defined. What does this work? What do you say?
Sure. Yeah. How does this actually work? um, Sorry, Lena, did you want me to go somewhere?
So I want us to look into the template itself.
Okay,
and
perfect.
see how it is defined,
Mhm.
I believe we can safely uh, look into the sensitive data protection templates
Mhm.
maybe for a moment, and then I want to stop and look into the uh, actually observability part of
Okay,
this. Yeah.
very good. Yeah, I'd love to show some things with SDP in particular. Um, So this is the template that we've created for the example you just saw, and you can see it has malicious URL detection enabled, prompt injection. We've set the confidence threshold too low and above. This is very sensitive. So the risk with setting something too low is that you might be catching things that are kind of innocent prompts. So this is where some tweaking is permissible. If you consider it to be such a risk that you really just want to cover all your bases, low is a good approach. If you're really only looking for sure things that are a problem, and in particular, like in certain content settings, we set it to high in our case for dangerous. And you notice that some things that are potentially dangerous still kind of got through. Um, so using this layered approach is how you would kind of catch the things that are, most likely not supposed to be there. In some cases, I've seen all lows when it's such a sensitive user-facing thing that family members may access, that has wide public reach. But in other cases, like I mentioned, with the medical researchers or students at a university or people who are, potentially looking up topics that would get flagged, but we should only be looking for malicious kind of application layer problems like trying to delete users. That's where we're gonna be more focused on, prompt injection. Excuse me. And then for sensitive data protection, there is a way when you create a template to just use a basic mode for sensitive data protection. And so that uses a series of predefined info types. I'll just you can see when you do the lab, but it's a very limited
You're not
set.
sharing. Yeah.
Yeah, yeah. It's a very limited set. So it's credit card numbers, Google Cloud API keys and credentials, passwords, social security numbers. So things that across the board are considered, pretty sensitive. But you could also select the advanced setting, which allows you to bring in your own existing SDP templates, which I'll show you in a moment, both for identifying, so exactly what types of things you want to identify, depending on what region of the world you're in. Maybe you want Thai tax ID numbers or Azerbaijani tax ID numbers, right? You can specify like sensitive data depending on the region that you're in. You could also, specify people's names. I don't think that's included. So if you wanted to catch when personal names come through, again, for creating a course, that would be a bad idea because if I wanted to build a course on Abraham Lincoln, I don't want SDP redacting that. The other bit that I'll show in a moment is you can select how it does de-identification. So we don't demo that, but you can actually test it pretty easily in the Google Cloud console, which is really fun to do. So let me just
While
pull
you're
that.
opening it, I just
Mhm,
wanted to mention that when you select the basic protection,
mhm,
the only thing that you get is kind of the warning that
mhm,
the data was detected.
right,
While when you use an advanced, you can
mhm,
add the modification, the identification
mhm,
configuration,
right,
and then the data will be modified, and the response will include the identified prompt version,
mhm,
which helps you to move forward. Because otherwise, the inspection guarantees that your prompt will be blocked.
right,
So if you want to detect, if you enable sensitive data protection in your model armor template, but you want to keep your option to move forward after the data is masked or removed or they identified using other methods, you have to use advanced and provide the not only inspection but the identification template as well.
right. So I'm going to quickly jump in and show each of those. First, the inspection template. Again, This is to actually flag different info types. So in our case, email address, street address, security data. There's over 200 that you can configure. But what I like is that you have the ability to test it as well. So you've got some input samples here and you can see what it's flagging, right? So it knows that this is an email address. I could maybe use, you know, a different one at. So you'll see it's able to flag that email address as well. You can even test this, on the outside with very large data sets, so CSVs and so forth. Um, but then in the de-identify template, that's where things get really interesting because
You will
for,
need
yeah.
something like a bit tricky. You will need to copy the inspection template in order
Yes,
to
if I
be able
bring
to
it in
inspect
here.
it. Yeah.
Yes, I believe we did have it in there. Okay, there we
We
go.
have our own.
Right, we
So,
have our own. Okay.
like,
Well, I think yeah, if you notice in our inspect template, we had credit card numbers listed, so that's why it's able to pick it up right here,
yes,
right?
but I believe if you jump to structured and back to free form, it
Hmm.
will auto-populate the sample.
Mm,
No?
no, yeah,
Okay.
this is just if I wanted to copy and paste in something from a CSV,
Okay.
right?
We have the interface somewhere. You have the link. If you scroll down a bit,
Hmm.
you have the populate with sample data.
That's right. All right, so let's try with structured and see if that goes.
With structured, I don't know. It
Mhm.
probably doesn't work well.
Right?
You
I
see,
don't
it
think
doesn't
so.
do any structuring actually. But in the free form, it is a glitch of the console.
Yes.
But in the free form, it reducts everything except for the credit card, and credit card it actually masks.
And actually, for those watching who are interested, I do have a separate lab just about doing structured freeform and images, so you can actually redact like names that are in an image file. And yeah, I'll see if I can add a link to that too, if you want to play around with that a bit. But basically, so how did we get? I wanted to show that example with the credit card. Yeah, this very bottom one. So this is a valid credit card number. It's not a real one, but it is a valid one because it passes the Luna algorithm. So if I did actually, let's just test it out. If I did 111 111 111,
It will pass it,
it
yes.
will pass it. Yeah, because that is not a valid credit card number. That's actually why.
Same
Right.
goes with the social security number. There
Ah,
are few
mhm.
prefixes
Yep.
which are like valid but never used.
Hmm.
And then if you pass it, they pass as is. So
Hmm.
sensitive data protection doesn't hide them,
Hmm.
which comes as a surprise first
Hmm.
time.
But if you're curious as to how to configure it, the instructions on how to configure it to mask part of a string are in the lab. But you can see here, I have a very specific rule to mask the first 12 characters and to ignore punctuation. That way, if people put dashes in the credit card number, it doesn't count as one of the characters. Otherwise, it would accidentally leave some additional ones unmasked. So you can try it out in the lab. Um, I think that's all I really wanted to show for STP, Leonid. Was there anything else you had in mind?
Yes,
Mhm.
actually, yes.
Cool.
If you can return back to the model armor template
Sure.
and open the template that we were using,
Mhm.
I would like to, or maybe I will just grab the screen.
Okay. Yeah, if you've got your yeah.
Yes, you know
Uh,
what? Let me share the screen instead.
cool.
And I want to actually, can you see my screen?
Uh, I can see it. Yep.
Okay, so I will switch to sensitive. Uh, no, actually, I wanted to open the model armor. Security, we have all nice security things hosted here. So in the model armor, you have some extra configurations, including logging configuration. And this is the thing that I wanted to stop for additional moment. It provides you with two options. It allows you to enable template operations logging and prompt and responses logging. As you see, we didn't enable template operations logging, uh, practically because at the essence, it is the same as the uh, audit logs that automatically enabled to administer all resources. So creation of templates, changes of templates is automatically logged. And you don't need to kind of configure it separately. However, a prompt and response injection logging, it is an interesting feature and it can be a bit tricky. When you run your application and it calls Model Armor, you want to be sure that everything works as expected. So you need it for governance, you need it for auditing, and sometimes you need it for simple testing. And from one side. From another side, you don't want to log all your prompts because this defeats the purpose of, for example, protecting sensitive data information. So when you enable this setting, the model armor will log all prompts and responses for you, meaning you don't need to add code into your application that writes the logs, and the logs don't go to the standard application log uh, on cloud logging or in another logging system as you configure. It always goes to the cloud logging, excuse me, on the Google Cloud in the project where the template is created, and you can control these logs and control the access to these logs. And then you can practically get these prompts written down without your developers uh, writing code from one side, and then you can look into the payload, including the prompts. Like this is what we asked: make lemon pound cake, and this is the result that we got. No matching found, meaning this is a perfectly legal result. And then let's look into the something that actually was blocked pathogen in Aaron's bathroom. And then we can see that things were found. I believe we will not find here the match for sensitive data protection. Uh, yes, we didn't try anything like this. But if the filter for sensitive data protection found um, matching one of these data types, then you would see also uh, the filtered, the identified prompt. So you can actually get insights about the work of your calls to model armor without a need to implement the code. It is especially important when you use integration mods that model armor has built in, or the mods that come with a agent platform, because then you don't have any way to put a kind of callback before or after the code invokes model armor, because the invocation happens on the backend. And then still you have this option to actually see the tracking, and you can later, once you finished your troubleshooting and you established that the workflow works as expected, you can just come and edit the template and remove the logging, and then hide all the prompts from the system completely. Back to you, Aaron.
Cool. Yeah. I'm seeing some of the questions come in, and I think they're very pertinent to what we're discussing. But Leonid, I know you wanted to mention also um, some of the different deployment types, if you feel like we've covered that? Yeah.
Yes.
Mhm.
So I mentioned a couple of times the word integration. So the main advantage of integration is that you take the control over what templates are in use and how the invocation happens from the development teams to the security team or platform team, because developer team is not longer required to actually write the code that interacts with the model armor directly. Uh, Today, we have two integration modes available. The first one came with the model armor service itself. So in the model armor service, let me see if I can actually show it. Let me first share my screen again. I was too quick to stop sharing. So let me return to the model armor. And in the model armor, except besides the templates, we have floor settings. And the naming may be a bit misleading, but this is the settings at the project level that says that once you configure all the filters, wait a moment, it can be enforced for all calls to the Gemini, as you see, inspect only or inspect and block, and also on all calls to Google managed MCP servers. This is the two additional built-in protections that you can enable, meaning that all invocations that are sent to Gemini models in this project or to MCP servers, Google MCP servers in these projects will pass through the model armor according to these filters as detected in the floor settings, and will be only inspected, and then if you enabled logging, logged, or inspected and blocked upon any violation found. And another mode is I can demonstrate it right now. Unfortunately, maybe we will have a different session focused on this. Another mode is implemented through the agent platform. It is a new collection of services that we have in Google Cloud. And this allows you to define the gateways that you call each time you want to reach out some custom MCP server or custom model that you host inside Google Cloud or externally. And then you can configure this endpoint with a model armor template to protect the incoming calls and returned results. And you can again enable it without writing any code lines through the platform configuration or delegate this work to your security team. And the main difference again is that agent platform enables you to do it with virtually any model and any other service like MCP server, while the built-in integration with within Model Armor is limited to only Gemini model and Google MCP servers. Yes.
Thank you, Leonid. So we've got some questions from the audience. Uh, Sridatya 9084 asks, um, if as AI runs on RLHF, which is reinforcement learning, if we somehow bribe the model for giving it a good feedback for the sensitive information, how could we deal with that situation? What would guardrails be? So the fact that model armor, and I'll just share that initial diagram we had. All right. Okay, I'm sharing now. Yes, the fact that model armor is decoupled from the model is a huge advantage here, because a lot of the problems with reinforcement learning eventually getting incentivized to do something they're not supposed to, um, all take place right here. So to have a separate system that has the guardrails, that is checking, and that's also, by the way, up to date. The team working on this is looking at all the cases of attempted attacks against Google, of all the cases where we see this in the wild. It's looking at all the latest research. So when people publish, here's how you do, reinforcement learning attacks, we're looking exactly at that to see what types of prompts people are using. That's where there's a huge advantage to have a separate system that's implementing the guardrail. So in that case, you're looking for attempts at adding, you know, incentive to doing things a certain way. But on the back side of it, of giving the sensitive data in return, that's where having SDP, I don't have output on the diagram, but that's where being able to catch what's coming back from the model is also extremely valuable. So that if you have a compromised model that is so susceptible to these things, even the most innocent prompt in the world, that doesn't look like prompt injection at all, can you know trigger that. You're still able to catch obviously sensitive data coming through the back. So that's yeah, I would just think of it at a high level. Being decoupled is a huge advantage here because you don't have the same biases, you don't have the same history. You've got kind of this independent perspective on what's coming in and out. Leonid, if you wanted to add something, I can move to
I
the
just
next one.
want to add that I believe there is no need in bribing the model. Even the completely valid standard model Google's model or other models can be perfectly fine doing the same by simply invoking some tools as part of the workflow process. And these tools will go and read this sensitive information provided to the model for referencing, and the model will incorporate this sensitive data in the response without original intention, just because it is probabilistically possible, and you can't avoid it no matter how many guardrails you will put. The chance is still there. So as a result, you may end up getting the response from the agent that contains sensitive information, despite the fact that you explicitly said, please don't send me any user data, for example. And as you said, this is why we generally recommend not only front the requests to the model with the model armor, but also to analyze the response from the model.
Very good. The next question is from Yang Lim. Is there any supervisor agent in the loop process? So in that 80K loop that we had, is there a specific agent that is, that's helping to see the steps are being followed properly and, that the agents are running? So there is not a devoted agent, but that role is handled architecturally. So you have an orchestrator. Through the orchestrator, you're able to define the attempts that are allowed, certain types of error handling, like if this breaks, what's the next step? And then once it's deployed, underneath the 80K framework is able to kind of catch the performance and each sequence that the model's going through. So I'd encourage Yang, if you want to check out the code lab that we have in the source code, you'll see a, how that's clearly defined, and B, kind of what the constraints are for each step. But then also in the 80K docs, we talk about how we're basically making sure that all these different agents are working together, as opposed to having a whole separate agent that's doing that role.
Mm.
But good, great
I
question. Yeah.
wonder, Aaron, if
Hmm.
what exactly is the intention behind the question? Because
Hmm.
when I read it first, I
Hmm.
thought that maybe supervision is to make sure that the loop actually is executed correctly and
I
not
see. Hmm.
uh, the work is done by each agent in the
Right.
way that it is intended. So I
I
want
see.
to
Hmm.
highlight that
Yeah.
it's not like the property of the ADK framework, to be honest. LangChain has a similar construct.
Hmm.
I prefer ADK from this perspective because it is more explicit in the functionality
Hmm.
provided by the built-in some of the built-in capabilities. So in the code, you can see that orchestrator agent actually
Orchestrator.
doesn't use any model.
Hmm.
It is
Right.
completely deterministic heuristic that explains the order of execution. So from the programming language perspective, it is a simple while loop. So it says
Right.
while X say no, do Z. And
Right.
Z is calling the research agent,
Hmm.
and X is running the judge on the results of the research and check if the judge approves the
Yes.
results.
Yeah. And that's
So
clearly defined in you
yes,
can actually see it
so
line by line. Yeah.
so by that, you can see orchestrator as the supervisor over the loop. But again, given the my interpretation of your question is correct.
Sure.
Otherwise, take the Aaron's explanation.
And either way, yeah, it may be equivocal. Like there may be different ones. So Yang, if you want to ask a follow up, we can definitely clarify. The next one comes from Jonathan Steven Zapata. How does Model Armor handle security between agents when they share context? Great question. What I think we've shown is that model armor takes place at various boundaries where information is coming in or it's going out. So, what happens when they're all kind of consuming the same thing? And on that point earlier about getting it in place as early as possible, this is why it's so important, right? Why do we want to catch this before it's exposed to all the agents? Why are we catching it at the application stage? Um, there's an option to use model armor extensively every time there's a call back and forth to a model, so that that context is getting reviewed each time. But really, for just screening what's coming in as context is the first place. I think that's the most efficient way. But yeah, Leonid, certainly,
Uh,
yeah.
I honestly like it is a very good question. However, I would like to clarify what is meant by share context. As far as I know, if we use the context in the meaning of the context window, the input, all this data that we input to the agent sends to the model each time, it is not shared per se. Because like we have the agent, and the agent through the implementation remembers this context, and it gets additional requests, and it just enhances, expands this context. We have the session context, which again the agent can use. So from this perspective, maybe the session variables or other values that get injected and can be reused by multiple agents,
Mhm.
they is referenced here. And in this case, again, it depends on what you want to protect. Let's take the current architecture. We have three right? We have three AI agents. We have
Mhm.
a researcher, we have a judge, and we have content builder. Now, do we need, and we have the application where the user asks to create a course and eventually gets a markdown with the course syllabus. Now, where we want to actually protect the models, where we want to put security boundaries. Do we want to put security boundaries between the judge and the researcher? We probably not,
Right.
because like the judge should assess the results of the researcher as is, and it doesn't go anywhere between the two. So whatever information, like how insecure or problematic there is, it doesn't change. And we know, because we configured this way, the judge doesn't use any tools. You can check me with the code, but
I
judge uses the model only, as far as I
Yeah.
know. Researcher uses Wikipedia,
Yep.
right?
In this example, yeah, it does. I
So
We have time for one more question, and this is a really good one, so I want to
okay,
make sure we get to it.
yeah,
Yeah.
sorry. So my point was, let me just quickly wrap up. So
Uh-huh.
my point is that we need to analyze per case where we want to put this security boundaries and protection with the model armor, because in many cases we actually don't need to protect every agent, and as a result, in many cases, it is completely okay to share the context of this in the session, and use the protection outside of the group of agents. Sometimes you will have to put it for each agent, and then sharing the context is not again a problem because each call to the model goes through the model armor.
Right.
Yeah,
Yep.
let's move forward.
Sure. So last one, this is from Kieran. Can AI agents be effectively used in network operations centers, service desk, and IT operations to automate incident management and root cause analysis? Very excellent question, very pertinent. So at Google, we actually recently published kind of how we're doing this. Our SRE team uses agents to help with a lot of this work. So we've got a blog that came out a few months ago about it. But basically, what the first thing I'd point out from having worked quite a bit with SRE as well is that a lot of incident management and automation, you know, there was a good blueprint for that before AI. And so I would say that the companies and teams that have gotten really good at SRE or SRE like principles, whatever they may call them, of setting relevant SLOs, of having a good alerting strategy, like only getting alerted on things that need human intervention and having automation kind of handle predictable problems. They're the ones who are also having the easiest time using AI to do these things. Whereas I think the hope or the wishful thinking is, oh, AI is here now. There's agents. I have nothing in place. Maybe I can just turn that on and it'll take care of things for me. So we're still at a transition period to get there. But where it's very helpful is in parsing things that are typically explainable in plain text. So giving context to alerts, being able to say, here's the user impact and so forth. Things that are less deterministic, right? Not just the actual percentages of an SLO's error budget, but or exactly what instances I need to spin up or shut down or what region I need to switch to. You, we really don't need AI to do that, period. Um, but where it's extremely helpful is in helping us debug novel issues, right? This is the first time I've seen it. Here are the error messages I'm getting. We have no playbook for this. Help me walk through this. So yeah, maybe in the future there can be some flows for that, but also on the security front, both with Google SecOps and a lot of what I'm working on right now with application security and CodeBender, which was just released today, using agents to identify potential problems, come up with some deterministic way to gate them, whether that's a test or some sort of threshold or being able to pass or fail a certain, like some certain outcome, like with verification. So it's not just AI guessing the whole way. There is actually a shell script we can run or, a test that we have in Python. And then going through and having the agent kind of help us come up with a solution to that. However, there has to be a margin for error, right? We need to have excellent monitoring in place. We need to have the ability to have human intervention until we're really comfortable with it. So it's an explosive question. Actually, I'll be doing another Cloud Live session, I think in a month from now, on this very topic. So, Kieran, definitely stay tuned for that. And Leonid, of course, the observability expert that you are, please chime in if there's something
I
I missed.
just
Yeah.
wanted to add that AI agents are great
Mhm.
in many things, but especially this year, we see the most do the most fantastic work around contextual input. So, like examples that Aaron brought, analyze often unstructured logs and try to match it to the what is happening actually, or analyze source codes from different components involved in the same transaction and figure out what can actually happen. But to automate incident response, you need to have a deterministic flow. If you have such flow, you can uh, like, I don't know if I probably can't recommend specific AI agents, but I'm very positive about the fact that agents exist that can be incorporated in such flow and provide the full automation end to end for this type of incidents. However, each time when you actually don't know, you have to have this different approach where the logic should simply stop. Otherwise, you're risking this cascade of different events that you roll back from just to get to another one, and it is simpler to bring a person, a human, into the loop as soon as possible. And I will join you to watch in 1 month Aaron's stream to see how it is done with the CodeMender.
Awesome. Appreciate you, Leonid, and thank you all for joining us and asking excellent questions. Hope you get a chance to go through the lab and connect with us. Ask us if you have follow-ups. We would really love to hear from you and understand what you want to see next. So thank you again for joining us on Cloud Live. Thank you, Leonid, and have a wonderful rest of your day.
Thank you.